Okay, so this is the rocks, the second set of notes for rocks. The first one was kind of an introduction or an overview. Today is going to be more specific about the igneous rocks. So the first one, if you remember the one thing that all igneous rocks have in common is that at one point in time, they were all heated up to the point where they melted. They were molten. Whenever that molten rock is underground, is referred to as magma. That's the term when it's underground. So like in this picture, that would be a magma chamber that's underground. It's full of magma. When it reaches the surface, though, then the name changes to lava.
You go back real quick. Okay, the next one.
So when it reaches the surface, it's not underground anymore. Then we call it lava. It's the same stuff. It's just a different term for it. All right. And here's a picture. I believe this is from Iceland. I think it was, I don't know, 15, 20 years ago. They actually had a new island form when a volcano that was in the ocean broke the surface. I think that's where this is from, if I'm not mistaken. But that's one of the few places where there's more land being formed, because that's not a super common thing. Where the volcano is still erupting and lava is flowing to the sea, it cools and hardens, and that's forming new land. All right, so with igneous rocks, especially when it comes to identifying igneous rocks, one of the things that you need to be able to do is to determine the texture. And I know anybody and everybody else that's not taking earth and space science, texture means how something feels. But in here, within the context that we're using it, texture refers to the crystal size within that rock. So here we have examples of the three main textures. There are a couple other ones that are kind of oddballs a little bit, but the three main ones, these are good examples of them. So you have coarse grain, fine grain, and then glassy. So with coarse grain, when you're able to determine that a rock is coarse grain, it has large crystals, and I can't even remember where I heard it, but it's kind of an arm length test. If you can hold the rock at an arm's length and easily see different crystals and different minerals, then that's coarse grain. So, like with this picture, you can easily see different crystals. You can easily see different minerals. There's whichever one's black, whichever one's kind of white. It looks like there might be one that's kind of goldish maybe. But those are large crystals. They're easily visible. As soon as you determine that it's coarse grained, that immediately tells you a couple of other pieces of information. So large crystals, it tells you that it cools slowly. So it takes a long time to cool down. The reason we know that it takes a long time to cool down is because of the large crystals. The longer that it takes that magma to cool down before it hardens, the bigger the crystals. So for something that cools down really quickly, it's going to have really small crystals. But something that has large crystals like this is going to need a long time to cool down. So we know, that it takes a long time to cool down. We don't know specifically, we don't have a numerical, value to assign to it, but we know that it cooled slowly. We also know where it formed, because there's only one place that it could form if it has large crystals and it cooled slowly, and that's underground. So the terms we use mostly is intrusive, but plutonic also means the same thing, and they both mean underground. But intrusive is the main one that we'll use. And so, just from being able to identify it as coarse grain, based on the size of the crystals, we know that it took a long time to cool down, and we know where it formed. Those are just kind of immediate pieces of information that we know just by determining what the texture was of the rock. The next texture is fine grained. So if you're using kind of the arm's length test, you're not going to be able to see different minerals. You're not going to be able to see different crystals really. If you kind of turn it, there might be like a little sparkle or something you might see, but it's all pretty much going to look to be the same color. So when you can determine that it's fine grained and it has these small crystals, we know that cools fast. It has a much faster cooling rate, because again, if it takes a long time to cool down, you have big crystals. If it takes a short period of time to cool down, you're going to have small crystals. The place that happens is on the surface, or extrusive, or volcanic. Like I said, we'll use extrusive. So primarily we'll use intrusive and extrusive to describe where this is happening. So again, just from identifying the texture, we know where this formed, and we know that it cooled much faster. The third texture is glassy. So there aren't any crystals in this because it cooled so quickly. It cooled so quickly that they just didn't have time to form. It went pretty much straight from molten rock to solid very quickly. So because the rate is very fast for the cooling, the only place that can happen is if it's extrusive. It's not going to cool fast enough for this to form if it's underground. The only way that could happen is if it's extrusive. With the cooling rates, you can kind of maybe think of it this way. With the coarse, say you cook a frozen pizza in the oven, and you just turn the oven off and leave it in there. I mean, it'll cool down, but it's going to take a long time because the oven's going to hold in heat, and that's what the earth does. It holds in heat, so those magma chambers cool down slowly. For the fine grain, that could be more like taking the pizza out of the oven and setting it on the counter. It's going to cool down a lot faster than if you left it in there. And then for the glassy, that would be like taking the pizza out of the oven and putting it right back in the freezer. It's going to cool down even faster. I'm guessing it probably wouldn't do much for the taste, but it would certainly cool it down more quickly. Does anybody know what we call this volcanic glass? Anyone? Starts with an O. So we call that obsidian. I don't know, maybe if somebody had heard of that or not. And it is glass, essentially. A couple of pictures of, it's been used for thousands and thousands of years for spear tips and arrowheads and weapons and all that stuff, because it's glass, it's sharp. Not very durable, but it's it's glass. The next texture, it's kind of a subset under glassy, and this does have a glassy texture, even though it doesn't really look like it. Or at least two out of these three things have a glassy texture. Let me put it that way. But these are the porous. what does porous mean? If something is porous, what does that mean? What does it have? Anyone? No one? Something is porous. So the picture of the sponge down there, there's a song, and one line of the song says, absorbent and yellow and porous is he. SpongeBob SquarePants. Because he's a sponge. Something's porous, it means it has holes. Kind of like a sponge. But with these, they're air bubbles, and they cooled so quickly that the air bubbles were trapped inside the rock. So much so that the kind of the gray one on the left, pieces of that will actually float, which is kind of cool. I mean, there aren't very many rocks that float, but that's one of them because, like I said, it has a bunch of air trapped in it. It's also extremely lightweight. When, if you pick up a piece of it, you don't expect it to be that light because you're used to rocks being rocks, not rocks with lots of tiny air bubbles in it that reduce weight. So kind of interesting. The fourth texture, this one's kind of an oddball. It's not super common, and we probably won't talk about it that much, but the texture is called porphyritic, and it actually has two textures because when it starts to, when the magma starts to cool, it's magma, so it's intrusive. But then during this process, something happens, if it's, through volcanic eruption or something, and then that magma that was starting to cool, as an intrusive rock, or to form an intrusive rock, is now on the surface and has become extrusive. So you end up with two different textures. You end up with some coarse grain crystals that had already formed, and then you end up with fine grain crystals that formed once it was on the surface. So like I said, it's not a super common thing, but it does exist, so it's out there. And then this kind of little, I don't know, visual aid or whatever, just to kind of try to show the relationship between the cooling time and crystal size. So at the top, big cooling time, you have big crystals. At the bottom, you have short cooling time, you have little crystals. I don't know if that helps or not, but it's out there. All right, so now is the part where you get to interact a little bit. So for this sample, what would the texture of that one be? Would that be coarse, fine, or glassy?
I'll say coarse.
I would totally agree with that. I would agree that that's coarse. So since we know that it's coarse, what would the cooling rate be? Would that be slow, fast, or very fast? So if it's coarse grain, is that slow, fast, or very fast? It has big crystals.
Slow.
Slow.
Good. Slow cooling time, because it needs all that time for those crystals to grow bigger and bigger and bigger. And then where does that happen? Is that intrusive or extrusive? Is that intrusive in the earth, or is it extrusive, exited the earth?
In the earth.
Perfect. Intrusive. Remember, it has to have that insulation to keep it warm So it can cool slowly instead of cooling more quickly. Good. How about this one? Does that look like coarse, fine, or glassy?
Glossy.
Not quite glassy. A little bigger crystals than that. Anyone else? It's the one right in the middle. That one's fine. So what's the cooling rate for fine texture? Is that fast, slow, very fast?
Fast.
Good. So fast cooling time or cooling rate. And then where does that happen? Is it intrusive or extrusive? This one's like putting the pizza on the counter.
Extrusive.
Good. Excellent. Extrusive. What about that one? Is that coarse, fine, or glassy?
Glassy.
It is glassy. Good. What's the cooling rate of glassy? Is that slow, fast, or very fast?
Slow.
Not that. Opposite end of that.
Fast.
The more opposite end.
Very fast.
Very fast. Good. And where does that happen? Is that intrusive or extrusive? Intrusive or extrusive?
Extrusive.
Good. And so the only place it can cool fast enough is going to be somewhere, in the environment. And then this picture is a good example to jump back to minerals. Remember when we were talking about fracture, cleavage, all that stuff? This shows conchoidal fracture. That was one of the terms that we had. You'd see like the little kind of semicircular shapes. Looks, the term conchoidal referring to seashell. This is a good example of it. This last one, which I really need to change the picture because it doesn't really look like what it should. Those are holes. Those aren't other minerals or anything. Those are just holes. It kind of looks like the surface of the moon. That wasn't my intention. So would that have a coarse, fine, or glassy texture if it has holes and bubbles and all that?
Wait, what were the options again?
Coarse, fine, or glassy?
Coarse.
Not coarse,
Oh.
because it doesn't have crystals. These are just bubbles and holes and all that stuff. Porous. What texture did the porous ones have? Anyone?
Then it's fine, right?
No, this one's glassy.
Wow. Okay.
So if one of the igneous rocks has the bubbles and all the holes and all that, even if it doesn't look glassy, it has that texture because it had to cool down so quickly in order to trap those air bubbles that it has glassy texture. And since we just did this one, we know that the cooling rate for an igneous rock with glassy texture is very fast. And we know that that's an extrusive rock. That's an extrusive process. It was good. Does anybody have any questions?